Chapter 5, Section 1. This is a sheet that you're probably going to want to print out. There's going to be instructions on here that you want to keep. In fact, I would strongly suggest that this step 4 in this process is something that you probably want to cut out and put in your notes. All right, you can write it down, but you can print it out, cut it out, tape it into your notes, and you'll have it. I could. You want me to do that right now? Going here, we got what? 3, 6, 7. There. Printed. Yeah, hold on. They'll be there. All right. Here's what we're going to do. It's polynomial functions. We're getting into learning about something bigger than just x squared. We're getting to learn more, it can be up to x to the 4th, x to the 5th, x to the 6th. We're going to start learning about those kind of polynomial functions. First thing we want to learn here is we want this in what's called a standard form. Now, you saw a standard form up here as ax squared plus bx plus c equals 0. Standard form in this case now is going to be combining all the like terms. You want all like terms combined. So here's an example. We have 5x to the 4th minus 3x plus 4x to the 6th plus 9x to the cube minus 12 minus x to the 6th plus 3x to the 4th. All those terms, number one, need to be in order. Highest exponent to the lowest exponent or constant. And you need to combine the ones that are similar. So we can take 4x to the 6th and subtract x to the 6th from it. Yes, we got a 5x to the 4th and a plus 3x to the 4th. We have, I think that's probably all we're combining in here, right? Probably, yep. So when we combine them all, this is what it's going to look like. And the next thing we're going to do is we're going to take those combined exponents and we're going to place them in order. So we're going to put the largest exponent first, which is x to the 6th. Then there's x to the 4th, x to the 3rd, x, and a constant. Okay? Once we get it placed in this order, now we can determine some things about this polynomial. But remember, the first thing we have to do is to get it into a polynomial set up like this. Largest exponent to the top, to the least, or the constant, down to the constant, and everything's combined, so you don't have multiple x to the 6's in there. The degree of the polynomial. In other words, what degree is that at, that equation? We always look at the very top exponent. In this case, it's 6. So the degree of this polynomial is going to be to the 6th degree. Pretty easy to look at, right? Pretty easy to figure out. You combine like terms, look at the very top one, you can tell what the degree is of that one. Next one is actually just as easy. After you combined all the like terms, you're going to count the number of terms that's in the polynomial. 1, 2, 3, 4, 5. That's how many terms are in it. Again, real easy. We can figure out what the degree is. We can figure out what the number of terms are in it. Now, this is the portion here that you need to stick in your notes. And it says, determine the end behavior of the polynomial. Look at the degree of the polynomial and the coefficient of the leading term. In other words, we look at this right here. and it's AX, and I'm going to call it to the N. All right? We look at that term. That's the one that's going to tell us what this thing's going to look like. If A is positive and N is even, the N behavior is called up and up. If A is positive and N is odd, the N behavior is called down and up. So we look at A. If A is positive and N is odd, then it's going to be down and up. This is the stuff that you're going to need to use to figure out, yes. Up and up. It could be like this. Could be this way. Yes. Yeah, you're only looking at that top term. Well, you're going to have that. You're going to have your ability to use it in test. Yeah. Yeah. I'm going to allow you guys to have this on a test, and if I don't remember, remind me. I'm sure you will. This portion here, actually this portion right here, is what you need on a test. You need to know this stuff right here. I could. I mean, I could have that up, or however it is. But you need to know. I want you guys to know how to use this. That's going to be the important part. Do I actually have you memorize this? No. I want you to know how to use it. So that means you have to practice it to know how to use it. There's really 3 problems to this section right here. That's all you need to do on that. Next part. What is the degree of the polynomial that generates the data shown at the right? What is the degree here that's generating this data? What are the differences when they are constant? To find the degree of the polynomial from the data table, you can use the different values. Okay, let's take a look at some examples of how we're figuring out what the degree is on this. That looks kind of tough, doesn't it? What do you think that would be? What is the difference between our y's? In other words, we've got our x's. What's the difference in our y's? Oops. $34, right? What's the difference in our y's? Here's 16, 4. This is what's called first differences. All right? What's the difference in it? So what we're actually doing here is finding a pattern of what's happening. What's the difference in this, 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 this? And then they go over in the second difference. They take this here, they take this portion here, and they do it again. What's the difference between these? 18. What's the difference here? 12. 6. 0. 6. And then they take a look at this. What's the difference? Minus 6, minus 6, minus 6, minus 6. And they're able to determine then that the differences are down to minus 6. And that's all they've really done. They've taken a look at the tables, figured out differences, and this is going to determine the degree of the polynomial. All right? Now, the third differences are equal, so the third degree of the polynomial function. The value of the differences is minus 6. We've done this 3 times. 1, 2, 3. That means we're at a third. It's a third degree. Okay? Literally is how simple this is. This just starts us off on using the big ones. We're going to get into, with this chapter, we're going to get into learning how to divide polynomials through synthetic division, through long division. We'll get into doing that, And this is just the start of understanding these polynomials. Okay? There's 6 problems to this assignment. Yep, go ahead.